Hey guys, today's going to be a video on some of the gates we've been learning in class. I'm going to start with the RSNOR latch, I'll cover T-Flipflops, and I will also do one on D-gates, D-latches. Alright, so first is an RSNOR latch. We've done them a couple times in class, and essentially what they are is a way of storing one bit of memory. Here is the most primitive RSNOR latch you can build. If you set the input, it stays on. And if you hit the reset, it stays off and stores memory. So you can have two inputs, here and here. And you say that can be your output. In that case, this is your set, this is your reset, and this is your set. There's not much to be seen there. You can also build this in a way that's scalable and optimizable by building it vertically. This is a vertical RSNOR latch. I can set it here and reset it anywhere along the top line. Alright, fantastic. Those are the two main ways that we build RSNOR gates, RSNOR latches. T-Flipflops. There are a couple different ways to build T-Flipflop. Here is a pretty interesting one. So, this T-Flipflop takes advantage of the new feature of Minecraft that Nathan showed me, which allows you to block a repeater. If another repeater powers it, when it turns on, whatever state the repeater had that is being powered sticks. So this lets us build gates really compactly. What happens here is when you hit an input on, the gate turns off a split second and turns back on a split second between inputs. So it saves what goes through here. It's very hard to get the timing right. You can see I'm doing it here. So one way you can take advantage of this is regulating the length of your pulse. This is a pulse limiter. When you turn it on, it pauses a split second before forcing itself to be back off. So any length of input you provide gets converted to a shorter length of output. You can see here that whenever I hit the lever, the state in the output changes. As long as your input is converted to exactly 3 ticks of length, then this will work. It's a little bit limited, so let's see if we can build one that's a little bit more versatile. So we'll start with a typical memory RSNOR latch as our internal memory component. Good night.
We'll get in there.
Great. I'm recording a video for the class right now.
Is that going to be on your video?
Yeah.
What's the video of?
We're doing gates right now, actually.
Oh, I would recommend using OBS.
OBS? What's that?
Or NVIDIA. You can use them to record screens.
Oh, yeah, I'm using Bandicam.
Ooh.
It's free. It works.
OBS is also free, and so is NVIDIA.
Eh.
Actually, I'm pretty sure NVIDIA comes with your computer.
Really? Oh. So many things to learn. Anyways, guys, yeah, so,
You approached Jamie, by the way.
that's my family. You can say hi. We're going to try to make this a little bit better. So when you get your input in, we can use it to directly set the gate. But typically in ordinary gate, we have two different inputs, right? Set and reset. We want to remove that and kind of black box it to the user and give them only a set option. So if it's in this state, yeah, we can just wait for them to turn on and it goes to there. But we basically want them to choose between set and reset. So if the input's set, if the other state is currently set, we want their input to be directed to the set state. If their input's not set, we want it to be redirected to the reset state. So we'll try to do this. We'll have two OR gates, two AND gates. This is a very uncompact design, which is just more to show the logic that's going on. So if it's set, then if set and input. So we'll put this off to the side here. So if set and input, then you need to go to this guy over here. So we'll do that now. On the other hand, if this side is set, oh, fantastic. This is going to be really weird. Then we need to go to this set. Okay, let's see if this works. Alright, we'll pull over here.
What do we need from the grocery store?
Chocolate.
Ha! It actually works! Or maybe it doesn't. Does it work?
Looks like we can
Yeah, it does.
like that.
So you can play with the delays, and the basic logic here is you pick which set signal you go to based on your current state in the circuit. You can get a lot more compact, and if you want to find compact designs for this, I recommend looking online. Otherwise, this will work just fine. Okay, finally we'll do D-latches. They're really easy.
Do you want more today?
This saves the input, this sets the input. Check it out, it's a D-latch. Thanks to Nathan for this. This is like amazing, and I had no idea about this. So I guess the last question is, how can you build something like RAM using a D-latch? So you'll have several D-latches, say like this, and you want them all to share one reset line. So you may do something like this. So you can set and reset them all at the same time. This can be a row. You need ways to access the output, so what you can do is you can drop a torch at the end of each of them, like so. And this is kind of weird because they're not on the ground, but you can do something like this. Okay, so now you share all the inputs, the outputs together, and then you just need to be careful to actually set the D-latches to be the inverse of what you actually want, which is not a big deal. And then you need a way to control the input, so you can do this. Well, actually, you'd this is not right. You'd want to be sharing across the columns, not the rows. So